Hello students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now, as I had said in my previous session that we will be having one more session on the factorial notation and the factorials. This is that session in which we will be learning how to solve more challenging questions on factorials and factorial notation. We will be learning how to factorize an expression containing factorials or how to solve an equation containing factorials. Okay? So without any further delay, let us start with our today's session. Now the first question says, write as a product by factorizing. There are three subparts, so let us start with our answer. Okay, subpart A. First subpart A says 5 factorial plus 4 factorial, so it is 5 factorial plus 4 factorial. And what did I say about when you are having more than one factorial in a question? Always express the larger numbers factorial in terms of the smaller numbers factorial. So between 5 and 4, which one is the larger number? Obviously 5. So we have to express 5 factorial in terms of 4 factorial. Okay. How do we do that? 5 factorial can be written as 5 times 4 factorial, and in case you are not familiar with these things, how am I getting 5 factorial equal to 5 times 4 factorial? I would definitely be asking you to watch my previous video on factorial notation. That is the first session on this chapter, the Binomial Theorem. Right now, we have started the Binomial Theorem chapter, and as I have done to my previous videos, the first chapter that I had taken was the arithmetic and geometric sequences and series. After completing that chapter totally in detail, now I have started with the Binomial Theorem chapter, and I will be doing the SL part and the HL part of IB Math, and this will be including obviously the IGCSE Additional Math level and the AS Math level. Okay. So 5 factorial, I am writing that as 5 times 4 factorial plus 4 factorial, which is equal to, I can take 4 factorial as the common factor, and within the parenthesis we get 5 from the first term and plus 1 from the second term. So this is 4 factorial times 6. This is the factorized form. Okay. Coming to the subpart B. 7 factorial minus 6 factorial plus 8 factorial. Which one is the smallest number? Obviously 6, and we have to express the 7 factorial and 8 factorial in terms of 6 factorial. Okay. So 7 factorial can be written as 7 times 6 factorial. 6 factorial stays as it is. And 8 factorial is 8 times 7 times 6 factorial. So this is equal to, I will be taking the 6 factorial out as the common factor between the terms, and from the first term we get 7, from the second term we get a negative 1, and from the third term it is 8 times 7, which is 56. Okay. So 56. What is this equal to? 56 minus 1 is 55 plus 7 is 62. Okay. So the factorized form is 6 factorial times 62. 7 minus 1 is 6. 6 plus 56 is 62. Therefore, factorized form of subpart B is 6 factorial times 62. Coming to subpart C, 3 times 9 factorial plus 5 times 8 factorial. What is this equal to? And between 9 factorial and 8 factorial, 8 factorial is smaller obviously than 9 factorial. So, we have to express 9 factorial in terms of 8 factorial. Okay. So, this is 3 times 9 times 8 factorial plus 5 times 8 factorial, which is equal to 8 factorial is taken out as the common factor, and it is 3 times 9 is 27. So, it is 27 plus 5 from the second term. So, it is equal to 8 factorial times 27 plus 5 is 32. So, this is our answer for the subpart C. Okay. We have completed this question. Therefore, let us move on to the next question. Simplify by factorizing. Again, factorizing, and first of all, we have to factorize and we have to simplify, because I am seeing that there is some part in the numerator and some part in the denominator, and we are having two subparts for this question. So, we start with our answer. Subpart E, it is 10 factorial minus 8 factorial over 89. I do not know about 89, but since I am seeing that we are having 2 factorials in the numerator, and out of 10 and 8, 8 is the smaller number, so we have to express 10 factorial in terms of 8 factorial. So, it is 10 times 9 times 8 factorial minus 8 factorial over 89. Okay. So, this is equal to 8 factorial can be taken as common, and this is 10 times 9 is 90 minus 1. Okay, now we can understand why did they give the denominator as 89. Okay, so this is equal to 8 factorial times 89 over 89, which gives us an answer of 8 factorial for the subpart A. Okay. Now coming to the subpart B. N plus 1 factorial plus n plus 2 factorial over n plus 3. No factorial, only n plus 3. Fine. And between n plus 1 and n plus 2, obviously n plus 1 is the bigger number. So, we write n plus 1 factorial plus n plus 2 times n plus 1 factorial over n plus 3. Okay. So, we come to n plus 1 factorial is taken common, and it is 1 from the first term and n plus 2 from the second term over n plus 3, and 1 plus n plus 2, 1 plus n plus 2, this is equal to n plus 3. So, we can cancel these two. Therefore, the answer for the subpart B will be equal to n plus 1 factorial. Okay. So you see, factorial notation questions, I am not saying that there cannot be difficult questions on factorial notation, but usually the questions that you get are not so very difficult. You are seeing the examples. Do you think these are difficult questions? Okay, I leave the answer to you. So let us move on to the next question. If n plus 1 factorial equal to 90 times n minus 1 factorial, this is 90 times. It is not 90 times n minus 1 whole factorial. Okay. Only n minus 1 is attached to this factorial sign. Find n. This is an equation involving the factorials. So, again, we will be the same technique between n plus 1 and n minus 1. Which one is the bigger number? Obviously, n plus 1. So, we will be expressing n plus 1 factorial in terms of n minus 1 factorial. Okay. So, we write n plus 1 times n minus 1 factorial is equal to 90 times n minus 1 factorial. Okay. And if we divide the entire equation by n minus 1 factorial, these two will be getting cancelled. So now we are having a simple quadratic equation. You see, n squared plus n is equal to 90, or n squared plus n minus 90 is equal to 0, which is, by Middleton splitting method, we can do the factorization, and it will be n plus 10 and n minus 9. I am not going into the details of Middleton splitting method. I have used the Middleton splitting method to factorize this quadratic equation. And in case you do not know right now, I am not having any video on Middleton splitting factorization technique, but of course I'll be taking up the quadratics chapter as well, and over there I'll be showing you how to get the Middleton splitting factorization. Okay, let me just show you for this particular thing. I can show you this is n square. I have taken this to be n square plus 10n minus 9n minus 90. This is what I have done, and I have taken these two terms together and these two terms together to get to this form. Okay. And since n plus 10 times n minus 9 is equal to 0, n is either equal to negative 10 or n is equal to 9. Okay. And if n is equal to negative 10, what is n plus 1 equal to? Negative 9. And we cannot have a factorial of a negative number. N minus 1, if n is negative 10, negative 10, negative 1, it is negative 11. We cannot have a factorial of a negative number. Therefore, we have to reject this. We cannot take this value of n. Therefore, we will be having the value of n as 9. N equal to 9 is our answer. Okay, this is our answer. So, we now know how to solve a factorial equation, an equation containing factorials. Okay, isn't that amazing? Okay, so students, this brings us to the end of this session. Next, we will be starting, we will be just having the basics of the binomial theorem and expansion in our coming video, and step by step we will be covering the entire chapter, both from the SL and the HL part. Okay, that is, we will be having the power of positive integer as well as rational numbers. Okay, so we stop over here for today. Thank for staying with me till the end. We meet again very soon in our next session. Till then, bye.